Hello, my name is Esther Kim, and I'll be going over Physics 2211 Lab 4 for oscillations. So these are some of the things we'll be going over today, and pause the video if needed. So for the introduction, the purpose of this lab is to observe the motion of a spring mass system with a mass in an oscillating arc. For the observational data, we'll be using a tracker, and for the computational model, we'll be using GlowScript. The goal is to determine whether the acquired model follows the energy principle, and for a brief preview of the results of the lab, it was determined that the system's total energy remains at a constant zero, and this depicts the energy principle. So these are some key points we'll be going over today. Newton's second law, which is written on here. We don't use the F equals ma formula. The velocity and position update formula, velocity on the left and position on the right. Law of conservation of energy, which is the system of the energy equals the work around the surroundings plus Q. And the potential energy formula is written here, which is as followed. The spring, kinetic energy, and the gravitational, the universal gravitation. And these are all key principles we have used before. So this is the initial condition we have right here. We can see that F grav is equal to F spring, and F spring is equal to mg. And the formulas below is just a breakdown of how the equation of the energy system is used with the work surrounding and the Q. So this is a video we have prepared for our tracker, and this is the oscillating data that is being followed with the tracker. As you can see on the bottom left that there is a data calculation happening for our x and y, and it is depicted above as well when plotting the points. So for the GlowScript code, we changed line 79 and 82. Line 79 we replaced with the gravitational constant, and line 82 we changed with the spring constant, and we solved it as you can see in this picture. Line 85 we also had the relaxed length of the string, which is also written based off the initial conditions we knew of. So continuing the GlowScript, line 88 through 90 is the spring length values, lines 93 to 96 is initial energy equations, and line 105 is where the while loop begins, and so several force and movement equations were used, such as the 9.524. That was the length of the tracker video, and that was written by seconds. Lines 124 is the velocity update formula, and lines 126 is the position update formula. So the two pictures on the first row is the computational results. There are some errors that we have involved. The system is not isolated to the surroundings, meaning that the work done from surroundings is viewed. And also there's human error in the tracker, which could explain why they're a little bit different from each other. The bottom row depicts the energy graph that we created, and the energy system was 0, and so we just set the initial kinetic energy, initial gravitational, and the initial spring equal to the final values of each of those. And is the energy principle satisfied? It was, because the change in energy of our system is equivalent to 0, as shown in the change in energy versus time graph, which is the picture we saw earlier as well. So the total energy is equal to kinetic plus the gravitational universal constant plus the spring. So the oscillation estimates, the oscillation period for the x position graph is close to 1.7 seconds, while the oscillation period of the y position graph is close to 1.5 seconds. We can conclude that it is best to calculate the spring constant using oscillation periods of not just one axis. And in the pictures, I've basically just drawn out where we see the 1.7 and 1.5 distribution between the x and y graph. Thank you for your time today.